Hi, welcome back everybody. Today we're switching our focus to active transport. First, let's start with our vocabulary. There are 5 words we want to remember: active transport, primary, secondary, co-transporter, and countertransporter. Active transport is the movement of material across a cell membrane that requires energy. There are 4 types of active transport. In primary transport, both solutes are moving up their concentration gradient. This means both solutes are moving from low concentration to high concentration. This requires ATP. In secondary active transport, one solute is moving down its concentration gradient and one is moving up. The solute moving down its concentration gradient produces energy or a momentum that will bring the other solute up its concentration gradient. A cotransporter transports both solutes in the same direction, whereas a countertransporter or exchanger will transport both solutes in different directions. Those are the 4 types of active transport. Now let's get into some problems. First, let's start off with identifying cotransporter or countertransporter. Pause the video to answer the questions and come back when you're ready. Number 1, sodium fluxes outward while potassium fluxes inward. This would make this a countertransporter. 2. Glucose and calcium both flux inward, which makes this a cotransporter. Number 3. Urea and chlorine both have an outward flux. This would also make this a cotransporter. Number 4. Sodium has an inward flux, whereas hydrogen has an outward flux. This opposite direction of flux makes this a countertransporter. Okay. Now we're going to use those same examples for primary versus secondary, but we're going to have a little bit more information on them now. Pause the video to answer the questions and come back when you're ready. Alright, let's start with number 1. First, we must check the direction of flux. In this case, the direction of flux for each solute is in different directions. So this means this is going to be a countertransporter. Now we must check whether the solutes are traveling up or down their gradient. Let's check sodium. We know sodium has an outward flux, but we need to check its concentrations. If we look inside, it has a concentration of 5 millimolars, and its flux is outwards to 50 millimolars. This means sodium is going up its concentration gradient, and potassium is traveling inward from 2 millimolars to 10 millimolars. This flux is traveling up its concentration gradient. Since both solutes are traveling up their concentration gradient, this would make this example a primary active transporter. For number 2, glucose and calcium are both traveling inward. This makes this a cotransporter. Glucose is traveling from 27 millimolars to 100 millimolars, and calcium is traveling from 17 millimolars to 25 millimolars. This means both of them are traveling up their gradient. This makes this example a primary active transporter. For number 3, the flux of both solutes are in the same direction. This makes this a cotransporter. Urea is going from 2 millimolars to 16 millimolars, where chlorine is going from 5 millimolars to 2 millimolars. So here, one is going up its concentration and one is going down. This makes this a secondary active transport. As for number 4, the flux of both solutes is in different directions, so this is going to be a countertransporter. Sodium is going down its concentration gradient from 35 to 14 millimolars, and hydrogen is going up its concentration gradient from 1 millimolar to 47 millimolars. So this is a secondary active transporter.
I got a fever, and the only prescription is more cowbell.